Here in problem number 2, what we want to do is write the linear program. Now the linear program, remember, is this. It's the objective function, like max or minimize some function, subject to, and then the constraints. We're just going to write the program. We're not going to solve it here. So as we start looking through this problem, it's like we've seen before. Farm encompasses this many acres, and then so and so and so on, and all this information. We'll go down to the bottom, and what does it say to do? How many acres of each crop should be planted to maximize the profit? So what we're doing is we want to find out how many acres of each crop to plant. So look what we have up here. We have soybeans, corn, and wheat. So that's going to be our X, our Y, and a Z. So let's write that. So I wrote those down here. What we're going to do is we're going to let X be the number of acres of soybeans to plant, Y, the number of acres of corn to plant, and Z be the number of acres of wheat to plant. Now, these are our categories, right? We have 3 categories: soybeans, corn, and wheat. So when we write our program, what we're going to have is, I'm going to write it this way this time. I'm going to write soybeans, corn, and wheat, and then we're going to have totals over here. I think on the written version of this, I put X, Y, and Z, but that's all right. Soybeans, corn, and wheat. These are our categories, and then down here, right, we're going to put our characteristics. So what characterizes each one of these crops here? So what do we have? If we go back here, we see what? Okay, there's fertilizer. Okay, we've got fertilizer for corn, soybeans, corn, and wheat, and then we have labor hours. All right, so I think what we have here, fertilizer and labor hours. So let's write something like that. So we're going to have fertilizer and labor hours. And then we're also, what we're trying to do down here, right, we want to maximize the profit. So down at the bottom, I'm going to write profit. Let's draw some lines to set these things off. I'll draw a line here. And now, what do we know about labor hours? Okay, so here we go for labor hours. So each acre of soybean requires 5 labor hours per week. So it's a 5 here. And both corn and wheat require 2. All right, so it's a 2 here and a 2 here. And then, if we follow it down a little bit more, it says soybeans bring a profit of $3,000. All right, so let's get that. Soybeans, we make $3,000 per acre. And then $2,000 for corn. So $2,000 for corn. And then $1,000 for wheat. So we'll put $1,000 in here. And now finally down here, we're told each week at most $3,000 can be spent on fertilizer, and at most 3,000 labor hours. So what we'll write over here, let's go over to fertilizer. Here's our total. Now it says back over here, it says at most. Now at most is a less than or equal to 3,000. And then also less than or equal to 3,000 labor hours. Let me fix one little thing here. This is actually 1,000. I had written 100, but I meant 1,000. So now let's write our linear program. So what we want to do here is we want to maximize P, our profit, and that is going to be 3,000 of those X's, right? $3,000 per acre, and then we have X acres. So this is going to be 3,000 X plus, and then here, 2,000 of those Y's, and then plus 1,000 of those Z's, plus 1,000 Z's, and this is all going to be subject to our constraints. Now here's our constraints. Here's one, and here's another one. But we also have another one, and I'm going to put that one in first. If you look back here, we have that the farm encompasses 500 acres. So we can plant at most 500 acres. So I'm going to write it like this. X plus Y plus Z less than or equal to 500. Does that work here? Right. This is the number of acres of soybeans, add that to the number of acres of corn, add that to the number of acres of wheat, and that's got to be less than 500, less than or equal to 500. So that's one of those lines that does not show up in our table. But now these other two do show up. So let's write this one right here. So that one is going to be 5x plus 2y plus 1z. That's less than or equal to 3,000. Right? Let's check it. So we're going to have 5 x's, 2 y's, and then 1 z, and that's less than or equal to that 3,000. And then finally, let's run this one right here. That's going to be 5x plus 2y plus 2z, and that's less than or equal to 3,000. And then, of course, we're always going to have these non-negativity constraints. X is greater than or equal to 0, y greater than or equal to 0, and z greater than or equal to 0. So here is our linear program.